In today's lesson, we're going to talk about formulas. Formulas are simply equations with more than one variable. Examples include area of a rectangle, area equals L times W, perimeter, P equals 2L plus 2W, and circumference of a circle, C equals pi times D. So where might we use this? So let's take a look at an example. Let's say you're writing a computer program where a person will enter the area and length of a rectangle, and your program will calculate and print out the width. To program it, you must tell the computer how to calculate the width. Because in the function, you need to have an equation, as I've outlined in red here, that says W equals, and then however you would calculate the width. So that means we're going to rewrite the original formula, area equals length times width. We call this solving for a variable, and we're going to set it so we get W by itself. So, using our general algebra rules, we want to get W by itself. Now, anything being multiplied by the letter we want to keep, we're going to divide by. Because again, our process is to get 1W. So by dividing this side by L, I'm going to get W, or 1W. But I did it to the right, so by algebraic properties of equality, must do it to the left. So I'm left with A divided by L. So to calculate the width, I simply have to take the area of the rectangle and divide it by the length of the rectangle to get the width. Let's look at an example of an equation you might tend to have to rewrite many times in algebra. We're going to solve 2x plus 3y equals 6 for y. And the phrase many times used for this is simply solve for a variable. And in this case, they're telling us we're going to take this equation and we're going to solve for y. So, it's just like a regular algebraic equation. I want to isolate the letter y and move everything else using my algebraic properties away from the y. So the first thing I'm going to do is I'm going to start away from the 3y and I'm going to subtract the 2x because again we want that to disappear, become 0. So I'm going to subtract the 2x from the other side. Now normally I could combine those terms, but 6 and 2x are not considered like terms. So what I'm left with is 3 times y is equal to 6 minus 2x. Now yes, I could have rearranged that to be negative 2x plus 6. Our commutative property of addition allows us to do that, but I'm going to leave it like this for now. The next thing I'm going to do is I'm going to divide by 3 because 3 is being multiplied by y and I want to get a 1y by itself, and 3 divided by 3 is 1. Now I will need to do that to both sides of the equation over here. So I am left with y on the left, and so right now I have a single fraction, 6 minus 2x over 3. Now there will be some cases where you're going to want to break this up. So how would I do that with one denominator of 3? I'm simply going to take the 6, each term, and divide them by 3. Take the minus 2x, the other term, divide it by 3. So if I simplified that, this would become 2 minus 2/3 x. So again, our final answer, y is equal to 2 minus 2/3 x. Are you still a little bit confused? That's okay. That's completely normal. It seems like such a foreign concept. So what we're going to do is let's review how to solve an equation in one variable, so we can just make sure we understand our basic algebraic properties. So we're going to solve 5 minus 2x equals 15 for the letter x, because that's the only variable we see in this equation. So again, the idea is to get x by itself. So when we have a number or expression being added or subtracted to the term that contains the variable that we want to keep, we need to use the additive inverse, and we need to, in this case, subtract 5 from a positive 5 in order for that to become 0, which then basically disappears. But because it's an equation, I need to do it to the other side. So I'm going to subtract 5 from 15. Now these are like terms. They're both numbers. So 15 minus 5 is 10. And I'm left on the left side still. Now this was a minus 2x, so we keep that minus. We treat it now as a negative. Negative 2x equals 10. Now the last step always is to work with the variable I want to keep. So in this case, I want to get rid of the negative 2 and turn it into a 1 in front of x. So I'm going to divide the left side by negative 2, because negative 2 over itself becomes 1x. And if I divide 10 by negative 2, 10 divided by negative 2 is negative 5. So in this case, I have my variable x equal to negative 5. Whereas on our previous example, we happen to have another variable involved. But the process was the same. Let's walk through one more solving for a variable problem. We're going to solve this perimeter problem, p equals 2l plus 2w for the letter L. So again, I want to isolate the letter L so that in the end, my answer will be the letter L equal to some expression. So again, I'm going to start with the basic algebraic properties. I have a 2w, a positive 2w being added to the 2l. So I need to remove that first. So the opposite of positive 2w is minus 2w. 2w minus 2w is 0w, which again, once it becomes 0, it's basically gone. Now, because I did it over here, I need to do it to the right. I'm going to subtract 2w from p. They're just not like terms, but that's okay. I'm going to write them both down. p minus 2w is now on the left side, and on the right side, I'm left with 2l. So again, the whole point is to have L by itself. So to do that, I need to divide by 2, because 2 over 2 becomes 1, and now I have 1L equal to, and that's what I want. So I need to divide both of these terms by 2. So my formal answer, p minus 2w over 2, will give me the length. And again, if you would need to break this up into two fractions, you could, by simply putting, let's go ahead and do that, put our p over 2 minus our 2w over 2. Now it does look like these two would cancel, so you could write p over 2 minus w equals L. Either of those should be a correct answer, depending on what is expected or what you're using this problem for.